in our day-to-day life, quite a few times we come across suspicious activities where trust is questionable. We all have come across situations like this and have was thinking what to do about it. Uh, wouldn't it be great if we had an opportunity to ensure the identity of the person we are chatting with or talking to in social media? Uh, at times, quite a few fake products are getting sold on online shopping sites. How can we be sure about the authenticity of this product? Wouldn't it be nice to know from where these organic products we buy come from? So the solution for all this is blockchain. Blockchain is the technology that brings in revolutionary change in the system and ensures that trust is provided by the system itself. This is the same technology that has been empowering the trusted transaction of Bitcoin and similar cryptocurrencies over a decade. So, in simple definition, I can put it across like it is a database. Um, it is a database which can maintain the records of transactions, which is continuously growing. If you ask me, is it something like spreadsheet like Excel? Yes, it's something like that, but it do have some special qualities. Uh, Consider we are making a payment. We rely on a secure payment gateway. Say Alice has sent money to Bob. We consider a secure gateway as ICICI or PhonePe to transfer money to Bob. So in every situation here too, if Alice has to book a Uber, she has to come with contact with Uber. It is like it is completely centralized, and Uber has also need to provide driver details. Like it also have to say driver that there is a customer waiting for you. So it is completely centralized. Only one person is having authority here. Consider a situation where Alice wants to buy a car and Bob wants to sell a car. Typically, Alice has to check the right do Bob has the right ownership of the car, and for that, the government needs to verify the Bob has provided necessary document proving his ownership. Alice has to check with the insurance company, and Bob has to verify the Alice credibility with the bank. For each transaction, there is an individual ledger here that you can see. So this is used by a particular person. So what Alice enters is only known to Alice, and what Bob enters is only known to Bob, and it is not like verified by any other person. So it's like it's not good because everywhere there is a different data. There is chances that people enter different data. So this is one problem with the centralized network. While blockchain networks are more powerful, you can see here it is a paradigm shift here. That is, instead of having a centralized authority, we can trust in the network itself. Everything is transparent in the network. Even there is a transaction here, because there is no trust in the person you are sending the money, you involve a middleman. So it becomes too centralized power. If this person is having capability to influence this person, then you would be like at risk. So there is no transparency in this centralized network. Whereas here, if there is a transaction between two people, other peoples in the node will verify it. They will do it because they will gain out of it. This is called mining process. And there is trust in the network. There is no centralized authority here, and there is transparency as well. Uh, so we learn what ledger is. So what we can record in the ledger is what we need to know. So every system is there. It has a different ledger for different business purpose. For example, our organization can keep a particular ledger for one business, and it can have number of such as the business increase. So what does this ledger consist of? This ledger consists of transaction. It is recording transaction, and this transaction there needs to be a condition under which the transaction occur. For example, consider here, the asset is transferred. Bob gives car to Alice. Under what condition does the Bob give car to Alice? It is that if Alice pays Bob money, then the car is passed. This is called contract. In blockchain, we say it as a smart contract. Uh, Consider a normal situation. Consider the same thing. Bob sells his car to Alice, but does not change the ownership immediately of the car, but he manages to sell it to another person. It's not a rare scenario in our society. We come across scenarios in our society where it's not just car, people cheat on land and many such things. But what happens here is in blockchain network, we are automating the whole story. Say Bob places a key and car in a smart garage, and he locks the garage with a software smart key. And so when the Alice has sent the money to Bob, the system, the network itself verifies it, and it automatically transfers the smart garage key along with the document of the car to Alice. So even if the Bob tries to like take money from another person, he'll never have the car's key with him, because it is automatically, when he receives the money, it is transferred to Alice. So it's like so automated here. So we are seeing blockchain. So what does this block contains? The block contains data. And how is the data placed in blockchain made more secure? Placing data in blockchain is it is placed not normally. Like if there is a transaction going on, the transaction is not placed like that. It is hashed in a way. It is encrypted. So it's the transaction. It might data can be transaction history. It can be the transaction. It is encrypted and placed inside the block. Then the another one is chaining of the block. It is including the output of this block, that is the encrypted output of this block into this block, and encrypted output of this block into this block. This ensures the changes made in one block will be modifying the following block. If there is any changes here, it will automatically modify this block. And the third one is any modification made must be validated by every node participating in the network. There has to be consensus. If there is no consensus, then the block gets rejected. So aren't we excited to know what does a block look like? This is just a temporary representation. There are many other elements also that involve in block. So it has a body and it has a header. So there are two parts here. The body consists of data. I told data will be, it will be encrypted. So we say hash of the transaction of data. If the body is consisting of number of transaction, it will be hashes of all those data. It is encrypted here. The hashes of data leads to what we call as Merkle tree. So that's what's present in body. And it is this line is to differentiate the header and the body. Then the block id is nothing but saying what is the status of the block. If the block number here was 1, it would be 2 here, and the next one would be 3. And the timestamp, which precisely says which year, on which day and which month this block was created, and on which second and of which second of this how it was created. It precisely defined the time at which the block was created. And what is this Merkle root? Merkle root is hash of the hashes of the transaction. You mean that it takes this data which is encrypted, it encrypts all of this and again encrypts it, everything, and then it is sent as hash output. So hash output of this stage will go and sit in the previous hash block of the next block. In the sense, what data is present in the hash previous hash here is the hash output of the previous stage. So each hash output is like a fingerprint. It is different for each and every block. So there needs to be a beginning for everything. So this is the Genesis block. This is the start of every blockchain network's first block is Genesis block. And the name is derived from the first Bible, that's Genesis. And Yeah, it's the hash, previous hash would be 0 because it is the initial block. And all these timestamp, I told you, it has everything in detail, precisely mentioned when it was created. It has the data, the hash value. The hash value is predefined. It will be 64 bits in size. There are various algorithms. We'll see about hash 256 here. And this nouns, this is the number for which the miners are struggling for. Once they get this number, after a lot of computation, they get their reward. So let's see how was the genesis block for blockchain. For blockchain, for Bitcoin look like. Yeah, you might have heard of Satoshi Nakamoto, who is an anonymous person. He is said to have hard-coded the blockchain. This was how the blockchain of Bitcoin looked like. He created it on 2009, somewhere around 6 o'clock. So he also received a reward of 50 Bitcoins. If he is alive, he would be really a crorepati now. So yeah, I told you there are various features in block. I mentioned a few. There is like difficulty level mentioned here. Yeah, there are a lot of things mentioned. I told you about the body, that is Merkle, that is Merkle tree. Then the hash of the hashes of transaction, that is Merkle root, which is mentioned here. All these big numbers that you see are all 64 digits in size, 64 bits in size. So let's consider a simple scenario, like we are considering hash SHA-256 algorithm, and this is the first block. So Mango is the data here, and see, this is the output. I mean, encrypted, output of this block. So as soon as I make a very small change to this data, that's I just added a full stop here. It has changed the entire hash, output. Because this data is involved in the calculation process, when the about the hash output is created. So any minor changes in data will change the hash output completely. So what about if this block is in a chain of other blocks? So you can see here, you can see this is the hash output which is present in the previous hash here. This hash output is present in the previous the next block here. So you consider this is a block. So I'll just tamper this block. So I have tampered this block. So what has happened is this data will be here, but because of the tamper that I have made, you see here the hash is somewhere on 0962. It was something different here. So it says when you tamper a block, it changes the output of this. Because this output is involved in the calculation process here, it also changes its hash output. So this also gets changed. So if same thing happens in distributed ledger, like a blockchain network making changes in block 2, then 3, 4 gets tampered because of the change in 2. This change will happen in only one peer. It will not happen in every peer. The other two peers will clearly mention that this is not the right data. So there is no consensus provided. They say this is manipulated data and this data is discarded. So the data which is present in the rest of this block is forwarded. Security increases as we know, as the block is increases, as more block is added. By the when we see the slide here, we get to know it is very immutable. Like any changes in the block can't be made, because if there is any changes, it rejects its data. It says it's wrong and you can't make changes. It goes with the data that is right, because most of the people will agree with this, because everyone have that data. There is proof with everyone that this is the correct data, whatsoever the data they have. If we say we have added a block in around 30 to 40 minutes, a block is already embedded inside the blockchain. So more the depth increases, the difficulty to crack to change the block also increases. This challenge. So as the block gets inside, it goes inside and inside, become more secure. And this is typically the block of interest, the middle block. So I told you, for any changes in the block, there needs to be validation. So what happens is here, there is a transaction which is going on here. The first stage in the distributor consensus, transaction is requested. This block will request all other nodes that it's making a transaction. Next, the transaction is broadcasted to the network of nodes. The data which is present here is sent to all this node. Okay. In the next stage, the network validates the transaction. It say, yeah, this is the valid transaction. After validating its transaction, the transaction is unified with the other transaction. You can see it is unified here. It was not like that before. It was just checking for it. Now it's unified. And the new block is added to the blockchain in a transparent and unalterable way. It can't be altered anymore. And the transaction is complete. This is how the distributed consensus happened. This is just a fact here. Banks are said to have made 6 billion from overdraft fees last year. This is the value of the 3 banks. So consider if banks had adopted to blockchain, it would have saved somewhere around billions. So they are all moving towards blockchain now, most of them. I'm saying the blockchain is completely distributed and it is decentralized network. It's like you're sitting in an examination hall where there is no invigilator. Can we expect that you don't copy? No person in the room copies because there is no invigilator. It's something like that. There is no centralized power. It's completely decentralized network. There is no central authority present to validate and verify the transaction. Yet every transaction in blockchain is considered to be completely secure and verified. Don't you wonder how is it? It's because of this consensus protocol, which is a core part of any blockchain network. It is a procedure through which all the peers of blockchain network reach a common agreement about the present stage of distributed ledger. I'll give you an example, an interesting one. For example, if I give money to Cartoon Network for Tom and Jerry, and it say, for example, these are 2 scenarios. It adds this Mr. Bean to my connection. I send this blocks to all of you, and I say I have given money for Cartoon Network for Tom and Jerry. You say no, this is not Tom and Jerry. You say you reject this. And the second scenario is this. You say, yeah, this is Tom and Jerry. You have paid money for Tom and Jerry. You have got Tom and Jerry. So new block added is one and only version of truth. You can't have multiple copies of truth. There is one version of truth which is shared among all other people. So there needs to be agreed by all nodes in the blockchain. So they reject this, they agree this one, and thus this transaction gets added to all the nodes that have accepted this. So there are really fives of tens of consensus algorithm. Have taken 3 of them. POW is proof of work. It requires validators to solve difficult cryptographic puzzles. You might have heard of miners, who are setting up a house with all those graphic cards because they are involved in mining. So yeah, there are a lot of puzzles that humans can't solve. They need a lot of power, energy. So what is the pro of this is it works in permissionless blockchain, though it's untrusted network. I told you it relies on energy, and it's like very slow to confirm transaction. Bitcoin and Ethereum is an example. For POS, requires validators to hold currency in escrow. That is, it is also permission less blockchain, but it requires cryptocurrency. Whereas this one, which is the fault tolerant implementation, it is reasonably efficient and tolerant against attack. Validators are known because there are certain number of validators they have set it. They don't accept all the others. Like, it's not open source. They themselves set the nodes. Like, these people has to validate. So validators are known. So it's totally connected. This hyper ledger fabric. This hyper ledger fabric is used also by IBM for food chain supply management using blockchain. They are using this hyper ledger for maintaining the food chain. So these are the 4 types of blockchain networks. blockchain technology that I came across. The one is public, private, federated, and hybrid. Public, yeah, it is open ledger, everyone can use, and the transaction is anonymous, means they don't know who has made the transaction. They only know what amount they have to validate, what amount of transaction they has to make, and it is immutable. We saw in the previous example there can't be any changes. If there is any changes, they reject it. So it is decentralized. There is no any centralized power here, and anyone is allowed to join and participate in the consent. Anyone can is allowed to validate, like we validated for the channels. So private blockchain, it is faster than this one. The single organization makes up this. It is a closed network because they don't want to show their data to the rest of the people. It is a closed network. And the federated blockchain is between the two or more organization. It is also decentralized, but it is extremely fast. It's like more secure. It is also closed network. It's not open, but it's between multiple organizations. Hybrid blockchain. This is also decentralized, but they have no authorized persons, like authoritative access. Only certain elements are private, like everything can't be seen by everyone. They say who can see what. So that is hybrid blockchain. This is also a closed network. These are the some of the companies that are moving towards blockchain, implementing them in their business. Google exploring the use of blockchain technology to enhance the cloud security, service security, and data protection. And Alibaba is using to track their luxurious goods using blockchain. Nestle, in supply of supply management to track baby food products, and it's also FedEx is also using it for settling customers' dispute. It's not just this. There are plenty of companies that are moving to blockchains. I just added a few. So what are the limitations, the drawbacks of current blockchain network? The first one being the transaction speed. Currently, the Bitcoin processes 7 transactions per second, and Ethereum processes 15 transactions per second. That is very low when we compare it to Visa, which makes 25,000 transactions per second. The block creation is being consistent. The block gets created at a regular interval of time, but as the transaction is not getting, it's not happening in a short period of time. This transaction is getting in queue. So every transaction is lining up in queue. It's said to be in every second is 60,000 to 70,000 transaction in queue in Bitcoin and Ethereum blockchain network. The major limit it's a major limit in public blockchain. So there is an infamous saying, the hidden centrality. What is this? It is very interesting. Even though blockchain preaches the principle of decentralized network, there exists an hidden centrality. That is, if more than half miners, half people who validate it, conspires to tell a lie, if they just think that, let's say a lie, never mind, they make a group and tell the lie, and that lie become the truth. So that organizations around the world are working on it. They are seeing people not to do, they are validating too. So this is a very serious problem, and the database storage network as well is a drawback. So this it's more creative because this what made me made me drawn towards blockchain, to know about blockchain. So I'll share some fun facts. So why you can't cheat Bitcoin? Because, for example, if you want to change the transaction here, this is 28th block you consider. So people are working on 40th block. If you really have to change this without other people knowing it, it is like everyone are studying one book. By the time they cover one book, you have to complete all these 13 books. It's it's very difficult. It's very expensive computing. It's like it's impossible. You can't cover all this. Can't change the data. It's not just going and writing. It is like you have to solve complex puzzles and all, and that too you have to finish within this block is added. So you can't cheat in Bitcoin. Mining is the process of adding a new block to the blockchain. I told the miners will validate it, so the block gets added, just like the Tom and Jerry that got added to all those people who validated that. So they say, yeah, we are going. The process is continuing. So what is the crypto mining? Mining is a process by which new coins are created as transaction on network is verified. Yeah, when anyone, they get a credit of some bitcoins, and bitcoin values are really huge these days. It's nearly a 30 lakh, they say, for a bitcoin. So everyone are working on it. Yeah, why is that? It's very high because it is very scarce. There is a rule that there will be only 21 million bitcoins whatsoever. It started in 2009, and for the future, whatsoever it is, there only will exist 21 million bitcoins in the world. That is a fact. So it's like 84% of all the bitcoins that are present is already being mined. So it's like, consider there are 3 people who are blockchain engineers, and there are 10 companies who want blockchain engineers. So there is scarcity of engineers. So what they do is they give a lot of money to hire them. So that is what happening here. There's scarcity of blockchain. So they pay more. The blockchain's value, there is inflation, and the value gets increased. And I told you that people like Chinese people are also having business of highly specialized computing machines. They are putting it, they are, others are, miners are making use of these mining machines for mining process. Yeah, I told nearly a third Bitcoin halving. I'll tell about halving of Bitcoin. Nearly 87% of Bitcoins are already being mined. There is only 26 lakh, 25,000 Bitcoins left. So you must all start mining. Only this many is left. So Bitcoin mining, yeah, it is a principle where if you had validated a transaction somewhere between 2009 and 2012, you would have received 15 Bitcoin. But if you had did it in 2012 to 16, it would be 25. That is what Bitcoin halving is. That is, after every 4 year, the amount of money that you are credited for validating becomes less, because the demand increases in future. So it is decreased. Yeah, have reached the end of the my PPT, and yeah, I'm want to answer your questions. Any questions?
Hi, Sneha.
Hi.
Uh, why we need a blockchain in education?
It's not just education. We need blockchain everywhere. Uh, when we consider academic credentials, like it must be made universal, recognized as verified, and it is verified. It must be universally verifiable, and the verification task is largely manual process. No, so if you are deploying blockchain solution in education, streamlines verification process, reducing fraudulent claims of unearned educational credits. People takes fake certificate, right? That will reduce, and it benefits transparency. There is accountability also, and other thing is like, you know about APPI uses blockchain to verify credentials with the help of smart contracts and machine learning. There are many things. There is Odem, which is also a marketplace for educational products and service. They use blockchain. The company connects the educators, students, and professionals to relevant courses and resources using blockchain. And one example, Sony Global Education has developed a new educational platform in partnership with IBM that also use blockchain to secure and share student records. So yeah, blockchain, yeah, it's used in education platform. Any more?
Yeah, hi Sneha. Out of curiosity, what are the other cryptocurrency available other than Bitcoin?
I was waiting for this. I knew, yeah, we will be very interested to ask this after knowing about the price of Bitcoin and mining. Yeah, there are several. To name some, apart from Bitcoin, there is Ethereum, which is programmable contract and money. There is Ripple, which is enterprise payment settlement. There are many. There is Dash. Dash is a privacy-focused Bitcoin colony. and there is Neo, that is Chinese market Ethereum, and it goes on. But not everyone, every cryptocurrency startups have been successful. There are also people who have failed, but these are some who have been successful.
Yeah. Okay, thank you.
Any other questions?
Sneha, can we
Yeah.
implement blockchain in agriculture?
See, a blockchain record establishes a level of trust between merchant who otherwise might not have experienced with other person, because blockchain is like many people are seeing. Uh, it's like the cat can't close the eyes and say no one is seeing me drink the milk. It is not like that, because everyone are watching you. They are waiting to validate your transaction, because that's how they earn. So it allows the market to expand and encourage healthy competition between the sellers. It might be like farmers data, harvest and yield, demand and safe. It might be soil moisture, climate data, then seed quality. All this, we can put all the information about the agricultural event onto blockchain to enable transparent and trusted source of information to all the farmers. So blockchain can help the agricultural space to evolve. Consider a decentralized blockchain system could improve transaction, market expansion, and product specific logistic throughout the agricultural supply chain. So yeah, there is potential for blockchain. Improved data sharing can help reduce 1 trillion problems of food wastage. Blockchain can also stem food fraud, which cause the global industry around 30 to 40 billion annually. So yeah, it's like it has benefits. Any
Okay.
more questions? So shall I end? Any questions? Okay, thank you.